In this part of the video, we'll be continuing with past exam papers from ZIMSEC, focusing on questions under 6. So from the June 2010 paper, paper 2, we're going to look at number 2, part C. So it says, it is given that the universal set contains 1, 2, 3, 5, 7, 8, and 9. A contains 3 and 5, B contains 1, 3, 7, and 9, and C contains 1, 7, and 9. Draw a fully labeled Venn diagram to show all the elements in each subset. Okay, so that's going to be number 2, part C. First one is drawing the Venn diagram. So okay, let me just from the So looking at the information that we have, right, we know that we have A and B and C. Everything is that is in C is in B. So that's 1, 7, and 9. So the other number that's in B is 3, which is also in A. So that's the intersection. And then the other number that's in A is 5. But 2 and 8 are in the universal set, but not in A, B, or C. So that's how you draw the Venn diagram and label everything. Then part 2 says, write down the elements of the following subsets. So it says A intersection B intersection C complement. So A intersection B, right? So if I'm going to try sketch that in green, so it's shading it that this is A intersection B, right? Intersection C complement. C complement is everything outside of C. So the intersection therefore would just be made up of 3. Then the next question says A union B complement union C. So A union B is everything in A and B. Complement, right? So that's everything outside of A and B. In green, that's that region. Union C. So it says including what's in C. So that will be that as well. Such that it then becomes 1, 2, 7, 8, and 9. And that's the answer. Okay, November 2010, paper 1, number 17 said, it is given that the number of elements in A is 18, number of elements in B is 11, and the number of A union B complement is 0. If this information was shown on the Venn diagram below, write down the values of P, Q, and R, the number of elements in each region. So, number of elements in A, we're told is 18. Number of elements in B is 11. So that means that from this information, Q would be, R, let's start with R, which is number of elements in B, right? So that would be 11. Such that Q would be number of elements in A minus R. So that's going to be 18 minus 11. That should be equal to 7. And then P, we are told that outside of A union B, complement is 0. So P is equal to 0. Right. So this would be 0. Writing that in green. Let me just. So that will be 0. Q will be 7. R will be 11. Perfect. And it says, for the same information, complete the Venn diagram to show the number of elements in each region where number of A union B is 29. So part B says, for the same information, right? Now we have number of A union B being equal to 29, right? And that can be possible if we maintain A and B and we have A, we have B, we have the universal set such that so we have A, we have B, we have the universal set such that this is still 0, A is still 18, because now it will just be number of elements in A and number of elements B is 11. So now A and B do not have an intersection, but when we have the union, it becomes 29 because it's 18 plus 11. So now from the June 2016 paper 1, we're told that it's given that the universal set has the numbers from 0 to 9. A is a set of prime numbers, B is a set of factors of 12. List the elements of A, right? So you have to know that prime numbers are numbers that are divisible by 1 and itself, excluding 1. 1 is not a prime number. So, prime numbers, we have 2, 3, let me just write that is A is equal to a set of prime numbers. So we have 2, 3, 5, and 7. Great. Part 2 says A intersection B. So B is a set of factors of 12. So let's look at which numbers are divisible into 12, right? So we got 2, we have 3, including 1 is also, 1 is also a factor of 12. 1, 2, 3, 4, and 6. Now when we look at A intersection B, what is common in both A and B? And that will be 2 and 3. Okay, and then part B says, find the number of A union B complement, right? So firstly, let's find what's in A union B. So in A union B, we are looking for numbers that are both in A and B. So 1 is one of them, 2, 3, 4, 5, 6, and 7. So what other number is in the universal set that's not included in here would then be in A union B complement. So those numbers are 0, 8, and 9, such that the number of elements in A union B complement are 3. So if you want to have more explanations on complements, unions, Venn diagrams, you can refer to the notes that I did on sets in the playlist on ZIMSEC Plastics, on ZIMSEC notes under the topic sets. Okay, then November 2015 paper 1. It's not so clear, but I'll try to read what's here. So it's given that the universal set has X, between 31 and 37, and x is an integer. It has subsets P, Q, and R such that P is the set of multiples of 3, Q is a factor of 99, and R is a prime number. Write down the elements of R. So we know that R is a prime number between 31 and 37, right? So maybe let's write the universal set. Let's just write everything in all the sets. So the universal set is between 31 and 37. So not including 37 so we have 31, 32, 33, 34, 35, and 36, right? And then we are told that P is a set of multiples of 3. So we have 33 and 36. Q is a factor of 99, which is going to be 33. R is a prime number, and prime number is divisible by 1 in itself. In this case, that's going to be 31, because when we look at it, 32 is divisible by 2, 33 is divisible by 3, 34 is divisible by 2, 35 is divisible by 5, 36 is divisible by 2, and other factors. So only 31 is a prime number. So now R, going back to the question, R only has 31. Write down the number of P union R complement. So let's just start by finding P union R. Right. So P union R is going to have 31, 33, and 36. And then P union R complement is going to have 32, 34, 35, such that the number of P union R complement is equal to 3. Great. List all elements of P union Q union R complement. So everything that's in P union Q union R. Let's start with those. So the union of those three would be 31, 33, and 36, right? And the complement of this would then be 32, 34, and 35. Then the next question is from June 2015, paper 1. A is a set of perfect square numbers less than 50. B is a set of even numbers not greater than 20. Given that the elements of set A and B are whole numbers, find A intersection B. So A is perfect squares less than 50. So when we look at A perfect squares, so that's going to be perfect squares, we can start it. 1 times 1, that's 2, 2 times 2, 4, 3, that's 9, 4, that's 16, 5, that's 25, 6, that's 36, 7, that's 49. So that's less than 50, right? And then B is a set of even numbers, not greater than 20. So that's 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20 is not greater than but it's equal to. So now it says number of, let's just find A intersection B to start with. So what's common in both sets A and B? So we have 4 and 16, right? So A intersection B is going to be 4 and 16, such that number of elements in A intersection B are 2. So that's the answer. Then the next question is from November 2014, paper 1. It says it is given that the universal set has 14, number in P is 7, number is in P intersection Q is 2, number in P union Q is 11. Show this information on a Venn diagram. Okay, so we have P and Q. So we have a universal set. We have P and we have Q. So we are told that number in P is 7 minus. So number in P intersection Q is 2. So this will be 7 minus 2. Number in P union Q is 11, right? So whatever is outside is going to be 14 minus 11, right? But when we then simplify this becomes 3, this remains as 2, and 7 minus 2, that's going to be 5. And if we want to then find what's in Q, we say 14 minus 5 plus 2, right? 14, everything which is in the Venn diagram is 14, right? And that should be 5 plus 2 plus, let's put it as y temporarily, plus y plus what's outside of P and Q, that's 3. So that's going to be 14 being equal to 5 plus 2, that's 7, plus 3, that's 10, plus y. So y is equal to 4, right? So then that becomes 4. So now putting that in that format is answer to our Venn diagram. So part B says find number in Q. Number of elements in Q is going to be 2 plus 4, which is going to be 6. Part 2 says number in Q union P complement. Okay, so we have to understand which part is being talked about. We'll try and highlight that in orange. So P complement is everything outside of P, right? Now including what's in Q though, because it says the union, that means including the 4. So I'll highlight that in purple for the union. So that then becomes, so what's in Q includes 2 as well. So that then becomes 2 . plus 4 plus 3. And 2 plus 4, that's 6 plus 3, that's 9. And then we go to June 2013, paper 1. Given that number of elements in A is 10, number of elements in B is 15. Find the greatest possible value of A union B. So the greatest possible value is when they do not have a complement. So that's the greatest, when there is no complement between A and B. So that will be 10 plus 15, which is 25. Then the greatest possible value of A intersection B is when everything is in one of them is contained in the other, which is always the smaller one being contained in the bigger one. So that's when A is contained in B. So that's when it's going to 10. So use the set notation to describe the shaded region in the above in terms of P, offsets P, Q, and R. So looking at what's shaded, we have an intersection of P and Q. P intersection of Q, union what is in R. So that's the notation. So because everything is in R is included. Now we go to the November 2013 paper 1. Given that the universal set is a set of numbers between 1 and 15, including, because it's less than or equal to, x is a multiple of 4 for A, B is a perfect square, and C is a multiple of 2. In the diagram, fill in the numbers of each subset. So let's just write those down. So multiples of 4 between 1 and 15, that's going to be 4 itself, 8, and 12. Perfect squares between 1 and 4, that's going to be 1, 4, 9, and that's it. Multiple of 2, that's going to be 2, 4, 6, 8, 10, 12, and 14. So now filling these, we know that A is a multiple of 4, and the intersection between everything that's a multiple of 4 is also multiple of 2. That's why A is contained in C, right? And the intersection between A and B is 4. And what's in other numbers that are in A are 8 and 12. Numbers that are in C but are not in A are 2, 6, 10, and 14. Numbers that are in B but not in C or A are 1 and 9. Numbers that are not in A, B, or C are 5, 11, 7, 13, and 15 itself. So write down, number B says, write down the relationship between sets A and C in set notation. So A is contained in C, so C contains A. Number part 2 says, find the number of elements in A intersection B intersection C. So let's try to shade that in green. So we want something that is A intersection B intersection C. So that's only this. So that's 4, right? But the number of elements in there is only 1. Great. The next question is from November 2012, paper 1, part B, which says, two sets A and B are such that A intersection B is a null set. There is nothing in A intersection B. A union B is the universal set, so everything is in A and B. number in A is 15, number in B is 25. Find the number in A intersection B. So, oh sorry, I should say A intersection B is not a null set. So we can sketch this. So we're told that A intersection B is not a null set, which means there is something that is common in A and B. Because, okay, just for clarity, this is saying it's not equal to a null set. So that means there is something in A intersection B. So we have A and we have B and we have the universal set. We are told that number in A, so let's make whatever is common in them X, right? And we know that number in A is going to be 15 minus X. Number in B is going to be 25 minus X. But number in A union B is 30, which is the whole universal set, right? So, and we're told that out here there's nothing, because everything in A union B is in the universal set, makes up the universal set. So 30 is equal to 15 minus X, which is A only, plus X, A intersection B, plus 25 minus X, which is B only. And 30 will be equal to 15 minus X plus 25 minus X, such that 30 is equal to 15 plus 25, that is 40 minus X, because minus X plus X, that's going to be 0, and we're left with minus X. Making X a real formula, X is equal to 40 minus 30, X is equal to 10. Right, so A intersection B, number of A intersection B is equal to 10. So that's it. Then we go to June 2012 paper 1, which we are given a Venn diagram with R, S, and T, and the universal set with the elements is shown. Use the Venn diagram to find R complement intersection S. So R complement, if we're going to shade it in green, this would be R complement, right, which is everything outside of R. Then if we're going to shade in orange, everything in S, that's this. So their complement is, sorry, their intersection is going to just be, it's just going to be this zone right here, right? And that number is 6. So I'll just remove the shading. So that would just be 6. Then R intersection S union R intersection T. So R intersection S, that's this set right here, and then intersection R intersection T. So R and T is going to be intersection here. Sorry, union R intersection T, sorry, not intersection. So that's those two. And looking at the numbers in that part, it's 4, 7, and 8. So it's 4, 7, and 8. Then it says number in R union S union T, right? So which means the number of everything in those outside of in those 3 sets. So that's going to be 1, 2, 3, 4, 5, 6, 7, and 8. So that will be 8. No, but it's it's complement here. Sorry, number of R union S union T complement. So the ones that are not in the union, so that will be 11 and 12. So that's going to be 2. sorry, the paper was not so clear, imagery. Then the next question says A and B are sets. Write the following sets in their simplest form. Right. So let's say we can maybe sketch it out. If we had A and B and a universal set, such that we had A and B and a universal set. If I was going to shade A intersection A complement, that's not, because there is no intersection between what's in A and what's outside of A. So that's just going to be an outset. All right. A union A complement, A union what's in A complement, that's just going to be everything in the universal set. And then A union B, A intersection B, sorry, A intersection B, so that'll be A intersection B, union A intersection B complement. So B complement would be, if I was to shade that in purple, B complement would be everything outside of B. So the intersection, sorry, the union between A intersection B complement, so that if that's B complement, the intersection between A and B complement will just be A. So in simple terms, this would just be A. So that's how you write it. So yeah, that's the last of the past exam questions from ZIMSEC questions and the sets.